How to calculate oxidation number or oxidation state easily. In this important lecture, I will teach you my personal trick to calculate oxidation number or oxidation state of any atom, ion or molecule. I challenge you that you will not find this trick anywhere. At the end of this lecture, I will teach you exam-based numericals of oxidation number. Firstly, I will teach you that what is oxidation number or oxidation state. Well, the apparent charge on an atom, ion or molecule is called oxidation number or oxidation state. For example, consider sodium atom, sodium ion, hydrogen atom and hydrogen ion. We know that sodium atom and hydrogen atom are neutral atoms. So the apparent charge on sodium atom is 0 and the apparent charge on hydrogen atom is also 0. While in the case of sodium ion and hydrogen ion, the apparent charge on sodium atom is positive 1 and the apparent charge on hydrogen ion is negative 1. So the oxidation state of sodium atom is 0, the oxidation state of sodium ion is positive 1, the oxidation number of hydrogen atom is 0 and the oxidation number of hydrogen ion is negative 1. Do not confuse if I say oxidation state or oxidation number because they both are the same thing. Similarly, consider iron atom, iron positive 2 ion and iron positive 3 ion. Here, the oxidation state of iron atom is 0, the oxidation state of this iron ion is positive 2 and the oxidation state of this iron ion is positive 3. Thus remember that oxidation number or oxidation state is the apparent charge on an atom, molecule or ion. Now I will teach you only 4 simple rules for oxidation state or oxidation number, and I am not going to teach you 10 or 20 boring rules which you often study in your school or college chemistry course. The first rule is that in free state, oxidation number is 0. For example, the oxidation number of sodium in free state is 0, that of chlorine molecule is 0, that of oxygen molecule is 0, and that of hydrogen molecule is also 0. While in the charged state, the oxidation number of an ion is the same as the charge on it. For example, the oxidation number of sodium ion is positive 1, oxidation number of zinc ion is positive 2, etc. Secondly, the oxidation number of hydrogen in its compound is positive 1, like in HCl, while the oxidation number of hydrogen in metal hydride is negative 1, like in sodium hydride. Thirdly, the oxidation number of halogen in its compound is negative 1, like hydrogen fluoride. Fourthly, the oxidation number of oxygen in its compound is negative 2, like in calcium oxide. Now using these 4 rules, we can calculate the oxidation number of any atom, ion or molecule. Let me start from simple and easy examples. Find the oxidation number of magnesium in magnesium oxide. Well, magnesium oxide is a neutral ionic compound. The overall charge on it is 0. So the sum of all oxidation numbers must be equal to 0. I write Mg plus O is equal to 0 because there is one atom of magnesium and one atom of oxygen in magnesium oxide. We know that the oxidation number of oxygen is negative 2 in its compound. So I put negative 2 instead of oxygen. Mg plus n to negative 2 is equal to 0, or Mg minus 2 is equal to 0, or Mg is equal to positive 2. So the oxidation number of magnesium in magnesium oxide is positive 2 and that of oxygen is negative 2. Also, positive 2 and negative 2 cancel out. So we therefore say that magnesium oxide is a neutral ionic compound. Secondly, calculate the oxidation number of potassium in potassium oxide. Well, it is also a neutral ionic compound. The overall charge on potassium oxide is 0. So the sum of all oxidation numbers must be equal to 0. I write 2K plus O is equal to 0. Here I write 2K because there are 2 atoms of potassium and 1 atom of oxygen present in potassium oxide. The oxidation number of oxygen is -2 in its compound, so 2K plus into -2 is equal to 0. Our 2K is equal to 2. Dividing both sides by 2, we get K is equal to +1. Thus the oxidation state or oxidation number of potassium is +1 and that of oxygen is -2. Remember that oxidation number of one potassium atom is +1 and 2 potassium atom is +2. So +2 and -2 cancel out and overall we get 0 charge on potassium oxide. Now let me take you to the medium level. Find the oxidation number of nitrogen in NH3. Well, it is a neutral molecule. The overall charge on it is 0. So the sum of all the oxidation number must be equal to 0. I write N plus 3H is equal to 0. Here there are 1 atom of nitrogen and 3 atoms of hydrogen present in ammonia NH3. We know that the oxidation number of hydrogen in its compound is +1. So I write N plus 3 into +1 is equal to 0. Our N plus 3 is equal to 0. Our N is equal to -3. So the oxidation number of nitrogen is -3 and that of hydrogen is +1 in ammonia NH3. Secondly, find the oxidation number of nitrogen in nitrogen dioxide ion. Well, it is an ion. The overall charge on it is -1. So the sum of all oxidation numbers must be equal to -1. I write N plus 2O is equal to -1. There is 1 atom of nitrogen and 2 atoms of oxygen present in nitrogen dioxide ion and the overall charge on it is -1. We know that the oxidation state of oxygen and its compound is -2. So I write N plus 2 into -2 is equal to -1. Our N minus 4 is equal to -1. Our N is equal to +3. Thus the oxidation state or oxidation number of nitrogen is +3 and that of single oxygen is -2. While there are 2 atoms of oxygen are present, so -2 plus -2 is equal to -4. Therefore, +3 -4 is equal to -1 and overall the charge on nitrogen dioxide ion is -1. Thirdly, find the oxidation number of phosphorus in PCl5. Well, it is a neutral molecule. The overall charge on it is 0. So the sum of all the oxidation numbers must be equal to 0. I write P plus 5Cl is equal to 0 because there is 1 atom of phosphorus and 5 atoms of chlorine present in PCl5. We know that the oxidation number of halogens in their compounds is -1. So P plus 5 into -1 is equal to 0. Our P minus 5 is equal to 0. Our P is equal to +5. Thus the oxidation number of phosphorus is +5 and that of 1 chlorine is -1, while that of 5 chlorine is -5. Now let me teach you some exam-based questions of oxidation numbers. Find the oxidation state of sulfur and H2SO4 or sulfuric acid. Well, it is a neutral molecule. The overall charge on it is 0. So the sum of all oxidation numbers must be equal to 0. I write 2H plus S plus 4O is equal to 0 because there are 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen are present in H2SO4. We are asked to find the oxidation number of sulfur, hence it is our subject. We know that the oxidation number of hydrogen in its compound is +1 and that of oxygen is -2. So I get 2 into +1 plus S plus 4 into -2 is equal to 0. Our 2 plus S minus 8 is equal to 0. Our S is equal to +6. So the oxidation number of sulfur is +6. Secondly, find the oxidation number of carbon in carbon monoxide and carbon dioxide. Well, we know that carbon monoxide and carbon dioxide are neutral molecules. So in case of carbon monoxide, I write carbon plus oxygen is equal to 0. We know that the oxidation state of oxygen is -2. So carbon plus N2 -2 is equal to 0, or carbon minus 2 is equal to 0, or carbon is equal to +2. While in case of carbon dioxide, I write carbon plus 2O is equal to 0. The oxidation state of oxygen is -2, so carbon plus 2 into -2 is equal to 0, or carbon minus 4 is equal to 0, or carbon is equal to +4. Thus, the oxidation number of carbon in carbon monoxide is +2, and the oxidation number of carbon in carbon dioxide is +4. From this example, we also learn that oxidation number of the same atom like carbon can be different in different substances. Thirdly, find the oxidation number of manganese in manganese oxide ion. Well, it is an ion. The overall charge is -1. So the sum of all the oxidation number must be equal to -1. I write Mn plus 4O is equal to -1. We know that the oxidation number of oxygen is -2. So Mn plus 4 into -2 is equal to -1. Or Mn minus 8 is equal to -1, or Mn is equal to +7. Thus, the oxidation state of manganese is +7 in this ion. Fourthly, find the oxidation number of carbon in calcium carbonate. Well, it is a neutral ionic compound. So the sum of all oxidation numbers must be equal to 0. I write calcium plus carbon plus 3 oxygen is equal to 0. We know that calcium is in second group and it has +2 charge. So the oxidation state or oxidation number of calcium is +2, and we know that the oxidation number of oxygen is -2. Hence I write 2 plus carbon plus 3 into -2 is equal to 0. Or 2 plus carbon minus 6 is equal to 0, or carbon is equal to +4. Thus, the oxidation state of carbon in calcium carbonate is +4. Finally, let me teach you 2 exception cases. In hydrogen peroxide, oxidation number of oxygen is -1, while in the case of oxygen difluoride, the oxidation number of oxygen is +2. Except these 2 cases, oxidation number of oxygen is always -2 in its compounds. I hope that you have learned my personal trick of finding oxidation number of any atom, molecule or ion.